This is the first new integration technique we're going to learn in Calculus BC. It's called integration by parts. If you remember, U substitution is basically the integral equivalent of the chain rule. This is basically the integral equivalent of the product rule. So it's sort of like the reverse product rule. One thing though, the U substitution really is exactly the reverse chain rule. It's not exactly the reverse. This is not exactly the reverse product rule. It's very directly related, but I wouldn't say it's exactly it. But for all intents and purposes, it is the reverse product rule. In fact, you can prove this or show how they come up with the rule by using the product rule. So I'm going to do that for you now so you understand where the rule came from. Alright, first of all, the product rule, they tend to use f and g for their notation, meaning the two functions are f and g. For whatever reason, whoever came up with integration by parts, they use u and v. So let's say we have u times v. That's our function, or two functions being multiplied together, u times v. And we take the derivative of them. According to the product rule, we would get u prime times v plus u times v prime. Well, I'm just going to change the notation there a little bit. Instead of writing u prime, I'm going to write du. And instead of writing v prime, I'm going to write dv. Okay, well, I don't care though about derivatives. We're talking about integrals. So let's take the integral of both sides. So the integral of u times v, derivative of it, equals the integral of, I'm going to switch that and make it v du, plus the integral of u dv. So I'm taking the integral of everything. Now if you notice, if you take the integral of a derivative, which you are right here in this area, okay, the integral and the derivative just cancel each other out. So you just end up with uv. And we're actually very close to the integration by parts rule. The last step is just to subtract this integral over. So we get uv minus the integral of v du equals the integral of u dv. Or it's typically written the other way. Just flip the equation over. So this is the rule for integration by parts. So as you can see, it's not exactly the reverse of the product rule, but it's derived from it, and it's the closest thing we ever get in integrals to the reverse product rule. Okay, I realize this may seem pretty abstract now, all these u's and v's, but I promise once you see some examples, it'll start to click. But basically, the thing you need to know right now is that this is your question. That's what they're going to ask you. It's going to be in the form of u times dv. And so you're going to have to pick the u and pick the dv, and then find these other pieces to fill it in. So let's do that. Here's our first example. The integral of x e to the x. Now part of the reason we have to have integration by parts is there are some things that the rules we've learned so far just won't solve. For example, integrals are really fragile, and what I mean by that is the rules we learned in AB for derivatives, they will do the derivative of anything. But that's not true of the integral rules. And here's part of what I mean about it being fragile. If I were to put a squared right here, then this thing would work with u sub. I could do u equals x squared, du equals 2x, just fix that 2 and move it over there, and I'd be ready to go, and I could do u substitution. But if I just do something as simple as take away that squared I added, u substitution no longer works, because I would get u equals x and then du equals 1, and I'd have nothing I could do with that x right there. So that requires integration by parts. So for now, I'm not going to tell you how to figure out which one is u and which one is dv. I'm just going to tell you that you do have to. You have to figure out u and dv. And for this particular problem, our x, this x right here, is going to be our u. And the rest of it, e to the x dx, is going to serve as our dv. Okay, if you remember with the product rule, the way I do it anyway, you have to find your f and your g, and then find f prime and g prime, and then plug everything in. It's similar here, only instead of starting with the two originals, we're starting with one original, u, and one derivative, dv. So to get du, we take the derivative, it's 1 dx. To get v, we have to take the antiderivative, and we get e to the x. e to the x is easy. Its integral and its derivative are just itself. Just so you know, you do not need to put a plus c there. We're just going to put a plus c at the very end of our problem, and that'll take care of all that. So don't worry about it when you're just doing these pieces. So if you look back at the rule, it's the integral of u dv is equal to u times v minus the integral of v times du. So we're not done yet, because we still have one more integral to take. But if you notice, the integral of e to the x dx is just e to the x plus c. So that is your first integration by parts problem. Okay, so like I said, I hadn't explained the u to you yet, and how you know which one is u and what piece to use is u. So let's do that now. How to choose u. It's a simple acrostic. I call it liate, which sounds like someone horribly mispronouncing a coffee drink. But L stands for log, I stands for inverse trig, A stands for algebraic, T stands for trig, and E stands for e to the x. Log is usually natural log. Inverse trig, you know what that is. Algebraic can also be called polynomial. So that's things like x, x plus 1, x squared, x cubed, anything of that nature. 2x minus 3, anything like that. Trig, you know what trig is, and then e to the x is obvious as well. But basically this tells you what order to do things in. Whatever is higher on that list is what you choose for u. So for example, in this previous problem, we had an x, which is algebraic, and we had an e to the x, which is e to the x. So since x is algebraic and it's higher on the list, it was the one we chose for u. Another way you can approach it is you just start at the top of the list and say, okay, does my problem have a natural log? If it does, that's your u, and then you just choose the other part as dv. If you don't have a natural log, then you just move to the next item on the list, inverse trig. If you have one of those, then you use it. If not, then you move on in the list. So in this one, for example, we have two pieces. We have an algebraic piece, and we have a log piece. So if you look back here, since log is first, it's going to be u. In fact, log is always going to be u. Just like with u substitution, if you have a natural log, it's going to be your u. And then dv is x squared. Part of the motivation, just so you're aware of why we choose one for u and why we choose one for dv, is mostly we want to pick the one that's easiest to take the antiderivative of. That's what we want dv to be, the one that's easier to take the antiderivative of. We actually don't know the antiderivative of natural log of x. We know the derivative of it. It's quite simple. It's just 1 over x. Whereas x squared really can go either way pretty easily. So we do the antiderivative of x squared, which would be 1/3 x cubed. So again, the rule is u times v. Actually, I'm going to put that in a slightly different order. It's still u times v. Remember, you're multiplying, you can write it any order you want. Minus the integral of v du. If you notice, that can be simplified. X cubed times 1 over x just equals x squared. And then, it's a very straightforward antiderivative. Add 1 to the exponent, divide by that number. Alright, next one, arc sine of x dx. Okay, so we really just have one piece here in a sense, the inverse trig, but the dx can serve as one of your pieces. And it'll always go with dv, no matter what. Dx always goes with dv because it's a derivative. So for this one, our u is inverse trig, it's arc sine x, and our dv is just the dx, and that's fine. Every now and then that's all the dv will be. The derivative of u, we have to use the rule for arc sine, and that's the derivative of the inside over the square root of 1 minus the inside squared. The antiderivative of dx is just x, and now we're ready to apply the formula. U times v minus the integral of v times du. So I'm going to go ahead and just multiply that x onto that fraction and get that. Well, if you notice, we can do this integral that we have now using u substitution. So u would equal 1 minus x squared, du would equal negative 2x dx. Well, we don't have a negative 2, so we have to divide that over. And then we can substitute. Okay, since we're pulling a negative 1/2 out front and there's already a negative out front, that'll actually change it to a positive. And we get du over the square root of u, which can be rewritten as u to the negative 1/2 du. So then we simply add 1 to the exponent and divide by that number. So actually the 1/2 is going to go away because we add 1 to the exponent, it becomes u to the 1/2. Divide by 1/2 cancels out that coefficient. So our last step is simply to plug in for the u. We get x times arc sine of x plus 1 minus x squared to the 1/2 plus c. Alright, and this lesson is going to continue in part 2, so make sure you check out part 2 of this video to get the full lesson.